Okay. My name is Trey Johnson, and this is my Lab 4 report on the spring mass system. The purpose of this lab is to test 2D oscillating motion of a spring mass system, compare my experiment data to a computational model to test energy conservation, and find oscillation periods. We started with a video that was given in the instructions of a mass oscillating while on a spring, and I used tracker on this video to get X and Y coordinates along with their timestamps, and I plotted these points on a spreadsheet and exported it to a CSV file. The CSV file was then used in our in our in our glow script code to generate a physics model of this same oscillating motion. And the physics model used the starter code and GlowScript and then added code to calculate for gravity and spring force. I also used the CSV file to help with this as well. Some formulas I used is for gravity, which F is equal to mg, and spring force is F equals negative K L minus L naught. Pictured in this graph down below is delta K, uh, delta gravity potential and delta spring potential, and delta E. These do satisfy the energy principle. Physics model versus tracker. You can see there are two graphs for X position and Y position versus time. In red is the experiment tracker data, and in blue is the model. The blue is a lot smoother because the physics model is basically perfect and has no other external forces or errors in tracking it, while there could be small errors in tracking, like not clicking the center of the mass perfectly every time. But overall, the results from the model closely mirror my experiment data, so I say that this is a success. Oscillation periods. This graph shows change in kinetic energy, gravitational potential energy, spring potential energy, and total energy over time. We can see that the kinetic energy and both forms of potential energy are constantly oscillating, which indicates that energy is being transferred between these forms as the mass moves. The kinetic energy is highest when the mass is moving fastest, while the potential energies are highest when the spring is either stretched or compressed, which aligns with what I would expect to see. Conclusion. In conclusion, there could be tracking errors, like when adding points on each frame, I do not click the exact center each time. Uh, I could have also set the scale wrong, not completely accurate as well. A non-ideal spring, like maybe the spring force is improper or wasn't measured correctly. Camera angle can also throw off my measurements as well. But despite this, the results closely match and prove that the energy is mostly conserved. So other than small errors, it is overall confirmed.